from a broken home. I gave you all the bricks that I own and know. I'm letting go. I'm breaking these walls down, breaking these walls down. If you want adventure, then fly to home. But if you wanna travel, then go alone. Yeah, what's the point in us if I never know? Yeah, if you're gonna leave, I'ma let you go. I'm tired of the pain. Go away. I'm tired of yesterday. Harder, harder. I fell where my demons dwell. My own little nightmare, I call it hell. Oh well, it's time to get back up, climbing and climbing. I'm done with this ride, is what I tell myself, so I could feel something else. Yeah, I guess I had my bad days, but it doesn't mean I lost my style. Darling, where were you when my heart was on the ground? I thought time would prove that you would stick around. I guess time stands still, a king without his crown. Now I'm breaking, you're faking, girl. You never made a sound. Oh, wait, I'm tired of the pain. Go away. I'm tired of yesterday. Harder, harder. If you want adventure, then fly to home. But if you wanna travel, then go alone. Yeah, what's the point in us if I never know? Yeah, if you're gonna leave, I'ma let you go. If you want adventure, then fly to home. But if you wanna travel, then go alone. Yeah, what's the point in us if I never know? Yeah, if you're gonna leave, I'ma let you go. Harder, harder.
Hello, everyone. Hello, and welcome to the Azure Cloud Security Meetup group. So, thanks very much, everyone, for joining us today. We're excited to have you with us today. So, we have a special guest, and we're going to be looking at, of course, Azure security. And we have a very interesting topic that I'm sure that you're going to enjoy. So, just some quick information regarding today's event, and also regarding upcoming events that we have set up. So today's event, we're going to have Andy Robbins that will be speaking. So let me go ahead and get my my picture away from that. So we have Andy Robbins that will be speaking. So Andy is, of course, a well-known name in the Azure security space, and actually in the security space in general. Andy has an amazing tool that's been out for years, very popular, useful tool called Bloodhound that many of us have used for many years when you talk about Active Directory security. But Andy does interesting content relating to Azure security also, and we're excited to have him with us in this group. But we also have other events that are upcoming. So we have other speakers that will have set up events for us. So we have Ryan that will be speaking on the 22nd of February. So same time, and Ryan will be speaking on Azure security also. So we have Kyle, and I think Kyle's session is set up for mid-March. And we have Joylene that will be speaking on the 1st of March, and Joylene will be speaking on DevSecOps for Azure will be joining this topic. So, but let's go to today's main event, which will be abusing Azure APIs. And we have Andy already on the line today. Hello, Andy. How are you doing?
Hello, everybody. Hi, David.
Yeah, hello. Hi. How's it over there in Seattle today?
It's actually a pretty beautiful day here, which is unusual for February the 1st. Usually it would be overcast and rainy, but it's a nice, beautiful, sunny day.
Yeah. It's been a bit crazy over here also in Oxford area in UK. So normally it's been cold all day, and then all of a sudden it becomes hot, very, and I'm sweating.
Yeah.
I'm almost sweating over here. It's like you can't predict the weather over here in UK. So yeah, nice. So Andy, I'm not going to spend too much time. I know you've done like interesting things, around just security in general. But you've put out more recent interesting topics on Azure security. And one of them, when I saw that, I was like, this is an amazing topic. I listened to your talk on that. It was just mind-blowing, the way that you really articulated the different parts that exist. And we're looking forward to learning from you today. So, ladies and gentlemen, if you have any questions, put your questions in the chat window. We will be reading the questions out to Andy at the end. And Andy, I'm sure, will be glad to answer your questions. So over to you, Andy.
Okay, great. So I do have a presentation ready here, and yes. I need to change the security settings on my laptop really quick to allow the application to see my screen.
No problems at all. No problems at all.
And of course, this is telling me I have to quit Chrome and reopen, so I will be right back. David, I apologize for that.
No problems at all. That's absolutely.
I'll be right
fine.
back.
Yeah, no problems at all. That's absolutely fine. So while Andy sorts that out, so with regards to the screen sharing, so I do have my good friend over here joining us, also just doing some stuff in the background. So he will be helping us to co-moderate. So if you have any questions, put your questions in the chat window. So hello, Sir Kofi, how are you doing today? Doing okay?
Hello, everyone. I'm glad to be part of this program. It's kind of amazing. I mean, definitely looking forward to this.
Yeah.
And judging from the audience, the chat going out there, it looks like everyone is excited as I am. So we're definitely looking forward to this. Yeah. And I hope you are as well, Sir David.
Yeah. It's a very interesting lineup, right? So what we try to do is we try to bring people who are like thought leaders in the Azure cloud security space, and we try to bring them all together. So, and again, Andy is just one of those people that is a thought leader when it comes to the aspect of security. And, I can't wait to learn what Andrew has to share today. So, Andy, how's it going?
Good. I think I should be set up now, and hopefully you should be seeing my screen.
Yes, we can see your screen now. So we'll go to the background and we'll let you carry on.
Okay. Thank you very much for taking the time to join us today, talking about abusing Azure APIs. Thank you, David, for that very generous introduction. If you don't mind, I like to present this way instead of having my full screen, so hopefully everybody can see this slide very clearly.
Yeah, that's absolutely fine, by the way.
Great. Okay, great. So yes, thank you, David, for that introduction. My name is Andy Robbins. I'm a co-creator of Bloodhound along with Rohan Vizurkar and Will Schroeder. I work at Spectre Ops. I'm the product architect of a piece of software called Bloodhound Enterprise. And on Twitter and other social media platforms, I go by the handle _Waldo with a 0. And yeah, if you would like to follow along with the deck by yourself, there's this bit.ly link, and the characters here are 3 I T T V N Y. So please feel free to follow along in the deck if you would like to. So what I'm going to be talking about is some of the same stuff I was talking about in a presentation I did, but we're going to look at what exactly API permissions in Azure are and kind of cover some of the basic vocabulary, the moving parts, and how you can actually interact with these APIs. And then we'll also talk about how these APIs can be abused. And then maybe some thoughts also for some preventative measures and some detection measures that you can put in place to see if adversary is actually abusing these configurations in an Azure tenant. So first, we'll kind of start speaking in the same language and kind of cover some of the more basic vocabulary in this context. I know not everybody is super familiar with Azure, and some of these concepts and some of these words are not exactly easy to understand if you don't already have this context. So in Azure, you've got lots of different services, lots of different types of objects, but for the most part, all of them fall into a predictable hierarchy in a similar way that on-prem Active Directory has a predictable hierarchy. When you think about domain trusts, domains, organizational units, and all those things, there are some analogies to be made in the Azure world. And so at the top of that hierarchy, for an organization that has created an Azure platform, you have what is called a tenant. And at the tenant level, you have Azure Active Directory administrator roles that are defined at the tenant level that then trickle down to other objects beneath that tenant. Now, some of those objects are here on the right. And here on the right, what we're looking at here, this is actually referred to as Azure RM or Azure Resource Manager. But when you have an Azure RM environment, that environment needs to have a trust established with a tenant. That trust grants anybody with administrative access on the tenant the ability to give themselves full control of anything within Azure RM. And within Azure RM, if you look at the Microsoft documentation, one of the privileged access systems involved here, they refer to as Azure roles, which is distinct from the Azure AD directory roles at the tenant. So you've got already two different permissions platforms or systems, if you will. What we also have under a tenant is we have lots of different kinds of objects under a tenant, including users, security groups, all kinds of different objects that don't exist in Azure RM. One of those is what's called an Azure Resource App. There are all kinds of different kinds of Azure Resource apps. At the Azure Resource App level, there is another privileged access system, and this system is referred to as API permissions. And all of these terms, they can be used differently depending on what documentation you're reading, or there may be different terms used. So this is still kind of a confusing area because all of these terms are kind of overlapping and reused, or different terms are used. But this gives you a very abbreviated view of three of the distinct privileged access systems in what I call Azure, which even the word Azure is kind of loaded because some people will tell you that only this is Azure. There's a pretty nice tweet that somebody put out that said Azure AD is neither Azure nor AD, but it has the name of both of those things that it isn't. So this is a very confusing space right now because of this language. So we're going to be focusing on this concept here, API permissions, which are defined at the Azure Resource App level, but they can actually interplay with these other privileged access systems. And that's what we'll look at in this presentation, how that interplay works and how we can abuse that as an attacker. So just to kind of lay it out, API permissions, they are atomic, uniquely identifiable privileges that are scoped to and defined by an Azure app. You can create your own Azure app and define your own API permissions, but those permissions will only be usable when interfacing with that particular app. You cannot, you cannot just create your own Azure app and then borrow permissions from other apps that will then be trusted by these other services. If you could, that would be very interesting, and maybe you can, good research area. And so API permissions, they form a distinct but also overlapping privilege system, and that system is distinct from Azure AD RBAC and Azure RM RBAC. Also, the different RBAC systems, including the new attribute-based access control system in Azure, and the Azure DevOps RBAC system, which includes some of the hierarchical permission logic that on-prem Active Directory has. So you've got all these different systems that work differently but interplay with each other, and it's just ripe for confusion and abuse. So API permissions, they come in two different flavors. App roles. So app roles are permissions that can be directly used by a principal that has been assigned that permission. And the other flavor is delegated permissions. So what does that mean? Delegated permissions, these are usable on behalf of a logged on user. And the user must also have that associated privilege against the service that that privilege is scoped to. And so you can imagine kind of a Venn diagram where my app has these permissions and my user has these permissions. And where those overlap, those are the delegated permissions that the app can use on behalf of the user. When we're looking at this from the attacker perspective, we're most interested in those app roles. And the reason for this is if I'm looking at the delegated permissions that an app can use on behalf of a user, the user already needs to have those permissions. And if the user already has those permissions, I don't really need to abuse that delegated permission. If I control that user, I can just go ahead and use that permission directly in the context of the user. No need to use that permission through an API or to, in other words, have somebody broker that permission request for me. Now that's true for the most part, but I can definitely see situations where somebody may have rules set up where a user cannot, for example, authenticate to a tenant from outside of the corporate LAN, but the app can, then that would give you an avenue of attack into the tenant that you wouldn't otherwise have. So let's talk a little more in depth about some of the technical pieces of this system. So we'll start off with the resource app object itself. And so a resource app, we could also call this a service principal. We could call it an enterprise app. And all of those words or phrases are accurate for describing, for example, the MS Graph resource app. So the MS Graph resource app, this exists in every tenant. Every Azure tenant will have this as an enterprise app. But the actual application object for this, it actually exists in the Microsoft Azure tenant. What you see in an Azure tenant is actually a per tenant instantiation of that Microsoft authored app. This app can grant and interpret API app roles. So for example, we could have there is an MS Graph API role called app role assignment .readWrite.all. All of the MS Graph API permissions, they follow this naming scheme. This naming scheme is not enforced for other resource apps. And also this name is not uniquely enforced. So you could have other apps that have this same name, but they're not going to work the same way. So if you're confused yet, that's okay. I was extremely confused by all of this when I first started learning all about it. And the other moving part we'll put in here is just a principal. And a principal simply means an identity that can be authenticated by Azure. So this can be a user, or it could be a service principal. It could be a managed identity, just something that you can log on with. So this API app role, it is scoped to the MS Graph Resource app. And this is a one-to-one relationship. It cannot be scoped to any other app. And the principal that we have has been granted the MS Graph API role. Okay, let's add another moving part. Let's add the Azure AD Directory Service service. So the MS Graph API, you can kind of actually think about it as an API for other APIs, or I like to think of it as an API broker, because it is one API interface that can actually interface behind the scenes with several other different services, including, most notably, I think, the Azure AD Directory Service. And the other moving part we'll put in place here is some kind of securable object. And a securable object is just any kind of object that you can control access to. So maybe a user, or maybe an app object, or maybe a security group, just anything. So the MS Graph Resource app, when we connect to this app and try to use some kind of privilege as this principal, it's going to broker that connection or that request to the actual service that will handle this permission request and modification request. And in this instance, we'll say that it's the Azure AD Directory Service. And the Azure AD Directory Service is the service that contains this securable object. And because the Azure AD Directory Service contains this object, it has the final say on who has permissions to modify or do anything against this securable object. So the Azure AD Directory Service is the ultimate authority on that, not the MS Graph Resource app. But as we'll see, there is a very special relationship between the MS Graph API and the Azure AD Directory Service that makes that a little more complicated than it sounds at first glance. So these permissions here that have been granted against the MS Graph Resource app, these are actually pretty difficult to audit for in the Azure portal. So the way that you actually have to do this is pull up the Azure portal, click on or search for Azure Active Directory, and that will bring you to your tenant overview. At this point, you would think, well, maybe I can just look at the MS Graph Resource app and just see who all has permissions against it. You can't do that. It's not that easy. So there is no one view to be able to audit all of these. What you have to do is you have to click on app registrations. Then, one by one, you have to click through all of these different app registrations. So for example, we'll click on the one that says this app has MS Graph API permissions. And usually it will not have that friendly of a name to let you know that. Then that'll take us to the view for that app registration here. On this page, we click on API permissions. This will show us what API permissions the service principal for this app registration has been granted for other resource apps. So when we click on that, we can see that, okay, here we go. So this app has MS Graph API permissions. So this app registration, it has been granted under the Microsoft Graph scope. It has been granted user.read and app role assignment.readwrite.all. So if you want to audit for these permissions that can be abused, you have to go through one by one at a time to do this. I do have a script at the end that will make this a lot easier for you. But if you're using just the portal, it's a huge pain. So I think it's important for us to understand the token issuance and token usage moving pieces here as well. And I like to talk about this because I really want to convey and help other people understand how these systems are different, but also how they interact with each other, how they overlap. So here's where we left off earlier. So our principal has this app role assignment.readwrite.all app role, which is scoped to the MS Graph Resource app. The MS Graph Resource app brokers connections to the Azure AD directory service, which contains the actual securable object that can be affected by this permission. When we want to actually use that permission to do some kind of modification against this securable object, our principal requests a token, and that token is requested from the Azure AD directory service. So the Azure AD directory service authenticates our identity here. But as part of this authentication process and this token request process, we tell the Azure AD directory service that our intended audience for this token is the MS Graph Resource app. So we authenticate here, but we're telling Azure AD that really what we want to do is interface with this API. The token that we get back will have an audience specified. And we can look at what that structure looks like a little bit. So this is a very abbreviated view of what that token actually looks like. When the principal gets that token, here's the token here, it will have that audience. That audience will be graph.microsoft.com. There will be another field in the token called roles. And that will list out all of the different API permissions or app roles that have been granted to this principal against this particular audience. Your token can only have one audience, and that is a critical security feature in how Microsoft issues these tokens. And if they ever change that, that's going to be very interesting from the security research perspective. Okay, so now we have this token, and now we can actually use it. So what does it look like when we actually use this token? So earlier, our principal authenticated to the Azure AD directory service. Now we actually have our token. We want to manipulate this securable object over here. So our principal submits a privileged post action to the MS Graph Resource app. At that point, the MS Graph Resource app forwards that request to the Azure AD directory service, or you could say it brokers the request. I like to use that word here instead. Then what happens is the Azure AD directory service, it looks at that token that was included in that post request. It interprets the grants or the roles in the token. So it will look at this, it will read this, and it will make an access decision based on this string. This string and its mapping to what permissions that actually grants, that mapping is not public information. So there are generalities documented by Microsoft about what permissions this will give you, but it is very brief and it is very opaque what that mapping actually is. So how this actually works behind the scenes, we have to make a little bit of conjecture at this point, or we can just brute force our way to understanding how it works. Once that process is finished, then the Azure AD directory service will grant access to that securable object, and our principal will be able to perform that privileged action against that object, whatever it was. Maybe they want to add a secret to an app registration. Maybe they want to change somebody's password. Maybe they want to create a user, whatever it is. And then obviously, if the access decision is a deny, then it will not allow that action to happen. So this is how this works with the API permissions. But we also have a parallel privilege access system that can be used with these same steps that has nothing to do with the API permissions. And that privileged access system are the Azure AD directory roles. So let's say, for example, that we have this Azure AD directory role called Cloud App Admin. And this is a default admin role that will exist in your tenant. That directory role is scoped to the Azure AD directory service, or it can also be scoped to the specific object. So you can have app scoped Azure admin roles. So instead of the arrow going directly to the Azure AD directory service, it could instead go directly to this securable object if we wanted to. Either way, it's going to work the same way with what we look at next. So this principal has been granted this role, Cloud App Admin. And now, when the user wants to use their Azure AD directory role, they again authenticate to the Azure AD directory service. They can optionally specify the MS Graph Resource app as the intended audience. And if they don't have these permissions here, and they only have this Cloud App Admin role here, thought I had a sneeze coming, then they're going to still be able to abuse this. So when we authenticate to the Azure AD directory service role, and we have this Cloud App Admin role assigned to us, the token that we get, it includes not only the fact that we have this Graph API permission, but there is also another field called WIDS. The WIDS field includes the globally unique identifier for the Cloud App Admin role. Now, if the user wants to use their Cloud App Admin permission through the Graph API, they can do that. So they would submit a privileged post action to the MS Graph Resource app. The Resource app or the API will forward the request to the Azure AD directory service. And at this point, the Azure AD directory service will interpret the WIDS in the token. It doesn't necessarily need to interpret the grants at this point. It can interpret the WIDS in the token to make an access decision, and then either grant access or deny access based on that interpretation. The interpretation at this point, this is more public than this process is. So if you look at the Azure AD admin role definitions, there are listed allow actions and listed deny actions. But in fact, there is more to those access decisions than just the allow and deny actions list. There's more to it than that. So in this way, we have two distinct but intersecting or cooperating or overlapping, if you like, privileged access systems. But in reality, there's even more complexity than what we see here. And again, just to recap on the top, we have the Azure AD directory roles, which can be used either through the Graph API or directly against the Azure AD directory service. And then we have the Azure API permissions, which need to be used via the API where those permissions are scoped. So that's all well and good, but how can an attacker actually abuse these permissions? So several months ago, Ryan Hausnecht and I, Ryan's going to be the next speaker for this meetup. He and I went through when we just basically brute forced our way to understanding which of these permissions can be abused and how, versus which ones cannot be abused with that same kind of abuse primitive. And we started to create tables like this. So the name of the Graph API role is here. So for example, we have directory.readwrite.all. And then whether or not that can be abused for the directory level roles. So global admin, for example, is a directory level role, or for the app roles. So for example, the Graph API roles. So directory.readwrite.all, that sounds pretty dangerous, but in fact, it's not good enough to be able to promote someone to global admin or to give somebody any Graph API permission or any API permission that you want. By comparison, role management.readwrite.directory does give you the ability to promote yourself or anybody else to global admin or any other admin role. It does not give you the ability to grant other API permissions. And app role assignment.readwrite.all is the exact opposite. You cannot grant global admin, but you can grant API permissions. What that means is that you can grant this permission, and we'll see in our example attack path how that lines up. And also with application.readwrite.all is not good enough to be able to promote anybody with API permissions, nor is it good enough to promote someone to global admin. We did the same thing for a couple of other abuse primitive categories, if you will. So with app registrations and service principals, how these objects can be abused, we can edit the owner or add an owner to either of those objects. And the owner of those objects, they get the ability to add a new credential to the app registration, which can then be used by the service principal. And so when we look at directory.readwrite.all, application.readwrite.all, and app role assignment.readwrite.all, these three are good enough to be able to perform those abuses. And an interesting case here is that app role assignment.readwrite.all is good enough to be able to add an owner to an app registration, but not enough to add a new credential to an app registration. But as an attacker, we can just promote ourselves to the owner, and the owner can add a credential. So we have these paths that start to form where the more actions we perform, the more privilege we are gaining. And there's not necessarily any kind of vulnerability here. This is just the way that the system has been designed. And the final one that we'll look at are with security groups, both security groups that are not eligible for admin roles and security groups that are eligible for admin roles. And again, we have interesting situations where one of those permissions are good enough to be able to add a member to a group, but not the owner. Or where one of these permissions is good enough for arguably more dangerous groups, the ones that are role eligible, but not good enough for the security groups that are not role eligible. So there's a lot of this. What I want to say, I mean, it's a very confusing system as far as what does this name mean compared to what privilege it actually gives you. It's very opaque. And when you read the definitions in the Microsoft documentation, for example, with directory.readwrite.all, I don't remember the exact language, but it's something to the effect of can read and write to all objects in the directory. So it really doesn't tell you a whole lot more than what these 4 words tell you. It's basically the same thing, just written in a longer form. There are other API permissions that we didn't have time to look into, and we're looking into now, and other people are looking into as well. But some of these permissions have very interesting and possibly abusable scenarios. So for example, if I have device.readwrite.all, or if I have device management configuration.readwrite.all, does that mean that I can push an evil PowerShell script to an Azure AD joined Windows device? Maybe, maybe not. This one that says privileged operations.all, it might not. We're not sure yet. So this is future research for us and for other people as well to dig into. So let's look at an example attack path. In our example attack path, we start off with a user principal in Azure called Matt Nelson. Matt Nelson, as we're going to see later, is going to have some privilege over this app registration. This app registration is called MyCoolApp. MyCoolApp, just like every app registration in Azure, will have an associated service principal. The service principal is the object that can actually authenticate to the tenant or to an API to perform actions on behalf of the app. And the service principal has the same name, MyCoolApp. Then we have an app role called app role assignment.readwrite.all. Another app role called role management.readwrite.directory. And an Azure AD directory role called global administrator. If you're not familiar, global administrator is the canonical, end all admin do thing. So if you have global administrator, you have full control of the tenant, all objects in the tenant, and every object in every subscription that trusts the tenant. You have complete control. It's basically the equivalent of domain admin or even enterprise admin if you're more familiar with the on-prem AD role. So if we start to connect the pieces here, Matt Nelson is one of the owners, one of the explicit object owners of this app registration in MyCoolApp. Like we said before, this app registration actually runs as or authenticates as the service principal. The service principal is the specific object that has been granted the app role assignment.readwrite.all app role. That app role gives you the ability to grant yourself or anybody else the role management.readwrite.directory app role. And that role allows you to grant yourself or anybody else the global administrator role. That forms our complete attack path. And when we were showing this to some colleagues at Microsoft, we kind of gave them a heads up about what we were going to be talking about before we made a public presentation about this. They asked a really good question. They asked, like, is this actually a privilege escalation? It's a good question. I think that it is, because how the system is configured lets us take a user who is not a global admin and turn them into a global admin. I think in that instance, I think it does qualify as an escalation of privilege. But it's a very good question, because really what we're doing is we're just using the configurations and review system works. There's no exploit here. This is just kind of administrative functionality and how the system has been configured. So here's our plan of attack. First, we're going to use Matt Nelson's ownership of MyCoolApp to add a new credential to that app. That new credential or secret we can use to authenticate to the MS Graph API as the MyCoolApp service principal. Once we do that authentication, we can
Yes, we can still see your screen. Oh, so just 1 minute. Apologies to interrupt, Andy. So, because people are mentioning that they are not able to hear your audio anymore. So, just to confirm, are you able to hear my audio? So, if people can confirm in the chat window. So, people mentioned that they can't. Okay, you can hear my audio. What about the audience? Can you hear me, audience? So, if you confirm in the chat window. So, people were dropping. Oh, they said they can hear me. So, Andy, if you say something, sorry. Let's see if people can hear Andy now. Can you hear Andy? Can you confirm if you can hear Andy? So it's so strange because I can hear you, but people said they cannot hear you. I'm not sure. Is it possible to join again? How about now? Can you hear Andy? People said they still lost. They said we can. It's so strange because they can hear me, but they cannot hear you.
Hello, hello. Can you hear me now?
Can you hear Andy now? If you can confirm whether you can hear Andy now. So just wait for a few seconds and people should confirm. Yeah, I think they can hear you now. Awesome.
Richard says yes. Okay, great.
Yeah,
great.
Okay.
Okay.
So, sorry about that. Yeah,
my apologies for that.
No problems at all. No problems. Yeah. Thanks very much, audience, for letting us know. Okay.
You know, maybe full screening this, I think that may have messed with some of the audio settings. So I'm just going to let it stay in the smaller screen. So hopefully you can see this okay. But the next thing we're doing here, we're going to get the tenant specific ID for the global admin role. We need that to look up the members of the global admins. And so we'll use the get Azure AD directory role member commandlet to list out the current global admins. And as you can see, Matt Nelson is not in that list. And also, just to confirm, Matt Nelson doesn't have any kind of other secret power to grant himself global admin. So this says insufficient privileges when he tries to add himself to the global admins group. So now that we've confirmed that, we'll get the object ID of the app registration object for the MyCool app. And that object ID is there. It starts with 7738, etc. And the app ID is 4A2D, etc. Matt Nelson owns this app registration, so we can add a new secret to that app. There is the plain text secret that we just added to that app. So now we've added a new credential to that app, and we're going to disconnect again from Azure AD and Azure RM, and clear out our tokens. Now we will use that new credential that we just created for MyCool app, and we're going to authenticate as the service principal for that app, and we're specifying the Graph API resource app as our audience for that token. So this will be what we need to do to actually use the API permission on behalf of the service principal. So now we have that access token, and we're going to use the existing privilege that the service principal had, and we're going to use that privilege to grant itself the role management.readwrite.directory API permission. Then we have to wait maybe up to 1 minute, up to 2 minutes for that to take effect. And once that takes effect, we need to get a new token from Azure that includes this new role management.readwrite.directory API permission. Our current token doesn't have that, so we need to get a new token. Our new token, we parse out the roles, and we can see there it is. We have role management.readwrite.directory now. Now that we have that API permission allows us to promote Matt Nelson to the global admin role. And so we just did that. Now Matt Nelson is a global admin. Next, we will disconnect from Azure AD and Azure RM and clear out our token. Then we will authenticate as Matt Nelson again. And recall that earlier when we started this, Matt Nelson was not a global admin. But now when we list out the members of the global admins group, or role rather, we'll see that indeed he has been promoted to global admin, and that completes our attack path. And at that point, we have all kinds of options for what kind of evil we can do next. So I think we should talk a little bit about prevention and auditing to see if this kind of situation exists in your Azure tenant. And recall earlier, we were looking at these slides here where to see who has permissions against the Graph API, you can't just go to one view. You have to go one by one through each of these app registrations to find service principals that have some kind of permission against the Graph API. And when an Azure tenant has been around for long enough, this list can be in the thousands or even the tens of thousands. So doing this by hand really isn't an option. It's just really not practical, especially because you want to be able to do this on a regular basis, and you're not going to click 10,000 different things in this GUI to audit that on a regular basis. So I did write a script that will help you automate that process. And that script is available at this GitHub link right here. And of course, I'd be happy to share this GitHub link in the webinar chat. Or if you did pull up the deck, you can go ahead and click on this yourself if you would like. But essentially what this script does is it automates that process of finding all the principals in your directory and then looking up for each of those principals, which of them have an API permission. And then what it also does is it filters out and it only shows you the results where a dangerous API permission has been granted based on the globally unique ID for that API permission. And so, for example, when we run that PS1 here, we've got we have the role ID listed out there, but not the human readable role. But this will give you the list of app registrations that you actually need to go look at to see what you can get rid of and pare down. So that's a starting point, but it is definitely not everything that you can or should do. What you also have to keep in mind is that these service principals, which the MS Graph Resource app is a service principal, and the app registrations, which if you have a local app that you created will exist in your tenant, these things also have those other distinct privilege systems that affect them. So it's not just the Graph API permissions that you have to worry about. It's also everything we talked about at the beginning. So it's also this hierarchy of privileged access and how those privileges inherit down through that hierarchy. With the exception of Azure DevOps, you actually can't prevent permissions from inheriting down through that hierarchy. And so because the Azure Resource app exists in your tenant, you have to look at the permissions in your tenant if you really want to understand the full picture of what exists or what's effective against this resource app. Additionally, certain objects in Azure have explicit owners. And so these owners are specified on a per object basis, not at the tenant level. But then you also have the concept of the owner role in Azure. And again, these objects can have explicit owners. And so you have to look at all of these different privileged access scenarios to really be able to understand the effective permissions on these objects. So say, for example, this service principal has one of those dangerous graph API permissions, and it needs that to function correctly. What you're going to need to do is you're going to need to look at who is the explicit owner of that object, because this principal will be able to abuse that, just like we saw in that video. You also need to correlate that service principal with the app registration and look at the explicit owner of the app registration. That's the scenario that we laid out in the video as well. What you also have to look at are the Azure AD directory roles and which of those have been scoped to the app registration itself, and which of those Azure AD directory roles have been scoped to the tenant that affect the app registration or give somebody control of the app registration. And in fact, there's actually even more than this, because where we started was we said, okay, this service principal has that graph API permission and it needs it. You also have to look at all of the other service principals that have API permissions that can affect this service principal, this app registration, this principal, the tenant, the directory roles at the tenant level. And so this spirals out of control very, very quickly. And that's why I think that the best remediation that I recommend to our customers, and I recommend to everybody here, get rid of these dangerous API permissions if you can, because unrolling all of this effective permission against those very highly privileged service principals is extraordinarily difficult to do effectively. And because of that, it is basically impossible for anyone to do on a regular basis. Some other mitigations you can put in place. They just introduced conditional access for service principals. They just introduced this in November of this past year. So you can limit where those service principals can log on. It needs to be in your corporate LAN, or it needs to be in a certain geographic location, or what have you. You can also use the Azure audit logs to detect some of these risky behaviors. So for example, what we're looking at here is that the MyCool app service principal has been granted the app role assignment.readwrite.all API permission against the graph API. There's more, and we can definitely discuss, and I think we're going to do a little Q&A, but I would say that my last thoughts are that if you're interested in Azure security, follow these people, including David, who is listed here. Definitely follow David and read all of his work. Carl Fossen is going to be on this meetup soon. And also Ryan Housenet here, listed here, is going to be on this meetup as well. These other folks as well, they are constantly putting out very high value content regarding Azure security. So if you want to stay ahead on what's happening with kind of the bleeding edge research, this group of people right here is a great set to start with. That's the end of my presentation. And I think what I'll do is I'll stop sharing my screen, and I think we've got time for questions.
Yeah, that was awesome. Thanks very much for that, and the really, really useful information there. So we do have some questions that's come through in the chat window. So let me go ahead and just scroll up and down and pick out some questions for you here. So I think one of the first questions that we got was from But Richard. And the question says, did they elaborate, as I guess that's referring to Microsoft, did they elaborate how they felt it was in a privilege escalation?
Right. So I actually see a comment here from YoniGrin1. He says, the reason it's not considered PrivEsc is the app was initially given very powerful permission. I think that echoes exactly what what the sentiment may have been. I don't want to speak for anybody at Microsoft, but I feel that was probably the sentiment that they had, was that, for this attack path to exist, the system had to be configured that way. So out of the box, when you buy Azure, this doesn't exist. This attack path doesn't exist. It is introduced as the system is configured. But in our experience, this configuration is actually fairly common. We have seen this configuration in many different customer organizations. And more broadly speaking, I would say that philosophically, I think Murphy's Law comes into effect here, is that if the product allows an administrator to configure something in a certain way, somebody will configure the system in that way. And I think that's why we see things like domain users being given local admin rights, or even worse than that, we've been in an environment where the domain users group had DC sync rights, and it had been there for years. So because the system allows these configurations emerge, and after they emerge, an attacker can take advantage of them.
That's a very good point. So it may not be something that's part of the system out of the box, but it's something that's common, and people in many cases don't have an idea of what they're doing. And then add to what you said, Microsoft Documents doesn't help to explain really what permissions you're granting. So it's very difficult to know, where the risks are in those cases. So I can see, I'm not sure if it's a question or a comment. From Sean, so he says, I can see YMS don't say, okay, yeah, I can see that. So let me pick out another one. So Sean said, I guess users should not be able to create apps. Is that what you recommend?
Well, there are lots of ways that you can lock this down. But I think what a lot of organizations run into is Microsoft has built this system to be used in a certain way, and third parties, like say, for example, a payroll system, just to give you an example, that payroll system, they may give you the ability to add an app into your Azure environment so that your payroll employees can use it to look up users, from your directory in the payroll application or whatever. So the architecture of users being able to add apps or install apps in an Azure tenant, it has a legitimate business use case more often than it does an abuse use case, just like with so many other things. Like I saw a conversation the other day where people were talking about remote desktop. They were talking about RDP, and RDP obviously has been around for 20 years or longer, and it has been abused by adversaries for just as long. And there are weaknesses with the protocol that kind of make it maybe easier to abuse than other protocols. But somebody mentioned, well, why doesn't Microsoft just replace RDP with something else? They're like, if you did statistics on this and you looked at the legitimate uses of RDP versus the illegitimate uses, the legitimate uses have to account for 99.9999% of the usage of RDP. And I think the same is going to be true with adding app registrations into Azure. It's almost never going to be abused when you compare it to how often it's going to be legitimately used for legitimate business purposes. So the business case, or selling the idea to the business of limiting these things, is a very, very hard conversation to have. It is very hard to convince people to make these features that they are paying for not available.
Yeah, that's so true. So now let me pick out a few more questions for big things to close. So I'll read two of Angelica's question. I guess that you've already addressed some of those. So, which is, how should we be given access to resources or subscription using Outback. I guess you've addressed some of those. And also, how can we prevent abuse of such permissions? You did address some of the different components to look at in terms of assigning access and some of the other ones.
Yeah, I think the only other thing I would add on top of that is that one of the things that's very important to understand is the difference between which roles and permissions can be abused and which ones cannot, because there are dozens and dozens and dozens of permissions and roles and different ways to manage access in Azure. And of those dozens and dozens and dozens, most of them cannot really be abused, in a way that gives you control of another object. So say, for example, I have the ability to read, the display name of another user. As an attacker, I don't really care that much, but if I have the ability to change that user's password, that I suddenly care a whole lot about. So knowing the difference between which ones can be abused and which ones cannot be abused, I think is maybe one of the first steps, and it's actually pretty difficult. And that's why following those people and keeping up on what they're talking about is so critical, because some permission that exists that, it seems to be innocuous or it seems to be harmless, someone does some research and they discover, oh, hey, by the way, if you have the Avere contributor role, you can execute PowerShell commands on a virtual machine.
Yeah. And that really ties in. So I'll just take about 2 more questions for the end. So I know we're running a bit over here. So that ties into what Yannick Green 1 is talking about here, which is actually like third-party tools that are also used for this kind of stuff also require some of these permissions. And in some cases, it's
absolutely.
So let me just take about one or two more comments. So I can see Angelica's comment on principle of least privilege. So that's absolutely right. And you're agreeing about how do we do this, because we have to pay Microsoft a lot of money to use conditional access. So by the way, that's where things like your script comes in. So at least people can start with something like that to understand where the risks are in their environment. And then, they can handle some of those risks, before you have the money to get Azure AD Premium P2. Yeah. Awesome. So that's been very, very useful. Richard, thanks very much for joining us today. So really, really appreciate it. It's been really awesome. Very, very interesting conversations in the chat window. And just to remind everyone that we do have exciting sessions that are coming up also in the Meetup group. So Andy spoke today. We have Ryan speaking on the 22nd of February, Carl speaking mid-March, and Joylene will be speaking 1st of March. Joylene will be speaking. So do follow our Meetup group so you can keep up to date on that. So thanks very much, Andy. I won't keep you longer than that. Thanks very much, everyone, for joining us. And we'll see you at the next Meetup event. Bye, everyone.